Schumann currently has 1,980 digital songs and downloads 30 more songs each month. Her older brother, Wei, currently has 2,590 songs, but he only downloads 20 more songs each month. The computer they share can only hold 5,000 songs. After how many months will their computer be full? So I'm going to make an equation, and I'm going to let M, because it asks me after how many months, so that's going to be my variable. M represents number of months. So already on the computer, we've got Schumann has 1,980 plus Wei has 2,590 already on the computer, and then plus 30 songs every month would be 30M, plus 20 more songs every month would be 20M, and we want to know when does that equal 5,000. So first I'm going to combine my like terms. 1980 plus 2590 is 4,570 plus 30M plus 20M is 50M equals 5,000. Now I'll subtract 4,570. So we get 50M equals 430. Divide by 50. And we get that M equals 8 point something. 8.6. So after 8 months, or after 9 months, their computer will be full. Solve the inequalities below. If possible, represent your solution on a number line. So I noticed that 30 is divisible by 5. So the first thing I'm going to do is divide by 5. So I get 2x minus 1 is greater than or equal to 6. Now I'll add 1 to both sides. 2x is greater than or equal to 7. So x is greater than or equal to 3.5. So on a number line, if 3.5 is right here, greater than or equal to means a closed circle, and we want every number that's bigger than 3.5. For this one, see, I'll add 5 to both sides, and we get negative x is greater than 8 minus x. I'll add x to both sides. Negative x plus positive x is 0. And we get 0 is greater than 8. That's not true. So this tells me there is no solution. Alright, consider this quadratic function. What are the coordinates of the vertex? So this is in vertex form, so my vertex is at h comma k. So it's at 2 comma 6. Is the vertex a maximum or a minimum point? Well, I see that the parabola is negative, so it's going to look like that. So the vertex is going to be a maximum. Graph the parabola, find x-intercepts and y-intercept. So I'll open up my paper. So to graph this, I need to graph the vertex, 2, 6. 1, 2, 3, 4, 5, 6. To find the x-intercepts, I need to plug in 0 for y. So I get 0 equals negative 2 times x minus 2 squared plus 6. I'll subtract 6 from both sides first. Negative 6 equals negative 2 times x minus 2 squared. Divide by negative 2. And I'm left with positive 3 equals x minus 2 squared. Now to undo the square, you take the square root of both sides. The square root of 3 is plus or minus plus or minus 1.73 equals x minus 2. So now we can split it into two equations. Positive 1.73 equals x minus 2, or negative 1.73 equals x minus 2. Add 2 to both sides, and we get x equals 3.73, or negative 1.73 plus 2 is x equals 0.27. So those are our x-intercepts. So 3.73 is almost at 4, and 0.27 is almost 1/3. Now to find the y-intercept, we plug in 0 for x. So we get y equals negative 2 times 0 minus 2 squared plus 6. Negative 2 times 0 minus 2 is negative 2 squared. We have to do the squared part first. So that's negative 2. Negative 2 squared is positive 4. Negative 2 times positive 4 is negative 8. Negative 8 plus 6 is negative 2. So the y-intercept is right here, and we can put the symmetry point on the other side right there. So here's the parabola. The auto repair shop is concerned about the reliability of its lathe. A lathe is a rotating piece of equipment used in restoring parts. The shop's owner measured the rotations per minute at various times over the course of a month. These are his measurements. So it looks like the data is already in numerical order. So we can easily make a box plot. First we need to find the median, the minimum, the first quartile, the median, the third quartile, and the maximum. So we already know the minimum is 250 and the maximum is 291. So to find the median, we'll cross off so that we can find the middle. So 257 is the median. To find Q1, we're going to take this half of the data, not including the median, and cross off. So 253 is Q1. And then Q3 is 263. So now we need to, we'll label our axes in just a second. Let's make the histogram data first. So we want class and frequency. So we've got numbers that go from 250 all the way to 291. So I'm going to make my classes by tens. So 250 is less than or equal to x, less than or equal to 260. 260, or sorry, not just less than 260. Less than or equal to x, less than 270. 270 less than or equal to x, less than 280. 280 less than or equal to x, less than 290, and then 290 less than or equal to x, less than 300. So between 250 and 260, we have to, I put the equal sign on the lower end because we needed 250 in this data. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times the data was less than 260. in between 260 and 270 would be 1, 2, 3. And then we have the equal sign on the 270 to 280. So 270 is going to go in there. That's 1. We have nothing in between 280 and 290. And then we have 1 in between 290 and 300. So let's label our axes. This is rotations per minute. 250. So I'll skip 1, 2, 3, 4. 260, 1, 2, 3, 4. 270, 1, 2, 3, 4. 280, 290, and 300. And I know that I need to go up to 10, so I'll skip by 2s. So 2, 4, 6, 8, 10. I probably could have skipped a little bit more, but that's okay. And then this is frequency. So between 250 and 260, we've got 10. So we're going to go up to 10 here. Between 260 and 270, we have 3. $270 and $280 is 1. $280 and $290 is 0, and then $290 and $300 is 1. So then to make our box plot, the minimum is 250, so we'll put that right here. Q1 is 253. So let's see, 260 is right here, so halfway is 255. Let's see. This is 252.5, 255, 257.5. So 252.5, it's a little after that, is 253. The median is 257, so that's a little bit before. Q3 is 263, a little after 262.5. So here's our box. And then we make a whisker to the minimum. And then we have to, the maximum is all the way at 291. So that's way over here. So this box plot is telling us that all of our data is clumped in between 250 and 263. And then we've got some data that's way over here. And we can see that on the histogram too, because the frequency is much higher right here. It means that there's more data points right in here. So the interquartile range of this data is Q3 minus Q1, which is 263 minus 253. So that's 10 rotations per minute is the interquartile range. It tells us that this middle 50% of the data right here has a spread of 10 rotations per minute. When reporting the center of this data or the typical RPM, would the mean or the median be more appropriate? Why? So this data is not symmetric, and it has an outlier of 291, because 291 is way bigger than everything else. So because the data is not symmetric, and has an outlier, the median is more appropriate. The mean is only an appropriate measurement of the center or the typical RPM if the data is symmetric. Here, if we were to calculate the mean, I'm going to go ahead and calculate the mean. Actually, no, I'm not. But we could calculate the mean, and we would see that the mean is probably artificially high. It's probably much higher than the median, because it's going to get pulled higher because of this 291. This 291, this outlier, is going to make the mean, it's going to pull the mean a lot higher than the rest of this data.